Hello everyone. In this video, we will discuss about how to consider two-way slab bending coefficient for various cases as per IS 456 table number 26. I already created 3D model in ETABS with slab beam and columns. The each slab I considered 5 meter by 3 meter so that it will be fall in the two-way slab. When you calculate Ly by Lx 5 meter by 3 meter, which comes 1.66, which is less than 2, so this slab considered as two-way slab. Let me open IS 456 table number 26. Table number 26, bending moment coefficients for rectangular panels supported on four sides with the provision for torsion at corners. These are 9 possible cases for two-way slab, in which the first one is interior panels. Interior panels means the slab having four continuous slab in the adjacent side, means the slab is having continuous slab in this side, left, right and top and bottom. So this slab we can consider as interior panel by considering these coefficient based on your Ly by Lx. Our Ly by Lx is coming 1.66, which means 5 meter by 3 meter comes 1.66, which comes between the coefficient between 1.5 to 1.75. We can interpolate this value for ratio 1.66 for shorter span. Similarly, we have to consider long span. Similarly, this is the ratio for long span. Here we don't need to consider any interpolation or any ratio. Directly we can take this value for negative moment and positive moment. Negative moments is at support. Whatever value you are getting as a reinforcement AST, that value you have to provide in the top reinforcement, and this is bottom. The next one is, the second case is one short edge is discontinuous, whereas it is written as continuous, but it's supposed to be discontinuous. One short edge discontinuous. In this slab, I will make all 9 cases for this slab itself. So the second case is one short edge discontinuous. By deleting this slab, this slab comes in the case number 2, one short edge discontinuous, which means this is one short edge. The for this side there is a no continuation of slab, but all other three side there is a continuous slab. So this slab to be considered for case number 2. And the third one is one long edge is discontinuous. To make that case, I undo this, I delete this one. So this slab to be considered as one long edge discontinuous. Similarly, you have to consider these coefficients, means whatever Ly by Lx ratio you are getting, from that if you are not getting the exact value of these 1.1, 1.2, 1.3, you can interpolate between these two values, the respective values. And the fourth one is two adjacent edges discontinuous. Let me again undo this. I delete these two slabs so that the case number 4 is two adjacent edges is discontinuous, means this edge has two adjacent edges discontinuous. So this slab to be considered for these coefficients. the case number 4 coefficients. And number 5, two short edge discontinuous, which means again I undo this, I delete these two slab. So these slab to be considered as two short edges discontinuous. This is your short span, and these two slab, these two side there is no continuous slab. So this slab to be considered as case number 5. And the sixth one is two long edges discontinuous, which means I undo this again, I delete these two. So this slab is to be considered for two long edges discontinuous. There is no slab in this adjacent side in the longer span. So we have to take coefficient accordingly. Here there is no bending moment for the negative, means there is in the support there won't be any moment, only in the span there will be a moment. And for longer span the positive and the negative have been given, which means due to the continuity there will be a negative moment at here and similarly here, and it slab span moment also will be there. So these two ratio have been given. The seventh one is three edges discontinuous, one long edge is continuous, which means I undo this, I delete this and this. So two short span is discontinuous and one long span is discontinuous. The case number 7 is three edge discontinuous, only one long edge is continuous, which means there is a continuous slab in the long side in one direction only. So this slab to be considered for case number 7. So the respective coefficient you have to consider. And the eighth one is three edges discontinuous, one short edge continuous, which means I undo this slab. So this slab to be designed for case number 8, only one short edge is continuous, which means only one side short span is continuous to the adjacent side. Case number 9 is 4 edge discontinuous, which means there is no slab in all four sides. So this slab to be designed for case number 9. I hope you guys understand about how to consider this moment coefficient for these 9 cases with respect to the continuity of the adjacent slabs.